Good afternoon, everyone. What I have up here on the board today are the answers to the Chapter 3 review. It's Tuesday afternoon, just after 1 o'clock. You need to make sure you take that test tonight before 11:59. It is on Edulastic, so make sure you take care of that. So we look at number 1 here, and all right, so check out number 1. The answer, the significance of the number 9.8 meters per second squared. Hopefully by now we've figured out that that is acceleration. All objects accelerate in free fall due to the pull of Earth's gravity, and that happens. That rate of acceleration is 9.8 meters per second squared. Numbers 2 and 3, pretty much self-explanatory. We've defined acceleration already, especially number 3. Number 4. We're talking about final velocity with average acceleration. Now, in this case, we're talking about an object being in free fall. We're kicking a football straight up into the air. So you're holding the football up first. The acceleration in all free fall problems is going to be 9.8 meters per second squared. So you just take 9.8 times 3.3, and you get the speed of the football just before it hits the ground, because it's in free fall, coming down at you, perhaps, for a total of 3.3 seconds. So that final velocity just before it makes contact is 32.34 meters per second. In number 5, we want to know how far does a car move during the time that it's accelerating from, it's decelerating from 17 down to 11 meters per second in a time of 4 seconds. Some of you, for the papers I've graded so far, some of you stopped when you got to this point, when you said, okay, my answer is negative 1.5 meters per second squared. That is not the case. You have to keep in mind that all you solved for here was your speed. Your acceleration. This is just your acceleration. So you have to take this answer and plug it into the position with average acceleration formula, because we're trying to find out, okay, how far did you travel while you were reducing your speed from 17 down to 11 meters per second. So position with average acceleration formula, you plug in the numbers here. The initial speed was 17, the time is 4 seconds, constant of 1/2, your acceleration is negative 1.5, we found it up here, and then you multiply by the time squared. 4 squared is, of course, 16. So once you solve all this, 17 times 4 is 68. When you multiply all this together over here to the right of the plus sign, you get negative 12. 68 plus the negative 12 is the same thing as positive 56. For number 6, a lot of you were telling me how you got this answer. Well, I took this number, multiplied by this number, and added this, and so on and so forth. That's not what I want you to do. I want you to explain that answer to me, this 56 meters. Explain it to me as if I know nothing about this concept. So what I wrote here is basically very similar to what I have on my key. The answer means that during the 4 seconds in which negative acceleration is occurring, the car travels 56 meters. All right, so the car is traveling 56 meters while you're reducing your speed from 17 down to 11 meters per second. So again, tell me what the answer means, all right, something similar to what I just said here, but do not tell me how you got the answer, because I can see that for myself in the previous problem. Moving on to number 7. Number 7 was the angular acceleration problem. We knew that by reading the problem, we found that my final angular speed is 4.5 radians per second. The initial angular speed was 2.6. So you subtract those two and then divide by the time. 4.5 minus 2.6 divided by... So 4.5 minus 2.6 is 1.9. 1.9 divided by 5 is this. Some of you, I don't know if it was this problem or another one, if you do 4.5 minus 2.6 divided by 5, you get 3.98. Okay? The reason why you get 3.98, your basic scientific calculator is programmed to follow the order of operations, in other words, PEMDAS. So you want to make sure you do all the multiplication first, and so on and so forth. So what your calculator says is it takes 2.6 divided by 5 and then takes that quotient and subtracts it from 4.5. And that's how you get the 3.98. You don't want to do that. To get around that, 4.5 minus 2.6, if you can do that in your head, that's good. But anyway, 4.5 minus 2.6 is 1.9. So make sure you hit, if you do it just in the calculator, 4.5, and I know you can't see this very well, minus 2.6, hit your equals button, and then divide it by 5. All right, so just be aware of that, because if this answer is bigger than like most of the numbers over here, you should really question that. So please keep in mind order of operations. Okay, number 8. A lot of people whose review sheets I've corrected so far, you're getting 3.46. And the reason why is you're not treating this as a negative number. If you read the problem carefully, it says a car travels west up a hill. Aha, up a hill. As an object is rolling up a hill, it's going to gradually lose acceleration just because of gravity. So you want to make sure that you indicate that in the problem. So you have negative 0.39 times 4, whatever that is, add 1.9 to it, and you get your final answer of 0.34 meters per second west. Make sure with all velocity problems you include a direction. If there's a direction provided, there's a pretty good chance that it's going to have to be part of your answer. If you don't include it as part of your answer, you're going to lose some, you're going to only get partial credit for that problem on the test. So please be aware of that. In number 10, you want to use the velocity with constant acceleration formula. The reason why is you know a distance, it's 64 meters. So the other formulas from the chapter really won't work here. So that being said, you have 2 times 4.1, which was my constant acceleration rate, times a distance of 64 meters. This is just 0, so we can just do away with that. So you're taking 2 times 4.1 times 64, you get 524.8. Do not stop there. Okay? Do not stop there. This is v sub f squared. If you leave this as 524.8 meters and say that's your final answer, meters per second rather, excuse me. If you're saying that's your final answer, then you're basically talking about breaking the sound barrier like Mach 1.5 or so. That isn't right. Because if you really analyze the problem, there's no way that can happen given the amount of space here. Only a distance of 64 meters with that rate of acceleration. So, this is v sub f squared. You want to make sure you figure out v sub f and report that as your final answer. In this case, 22.9 meters per second south. Number 11. The acceleration of the car is 30 miles per hour per second squared. We're trying to find the amount of time elapsed. FYI, this is actually based on, most physics is based on real-world application anyway and examples. This is based on Top Thrill Dragster at Cedar Point, if you've ever ridden that. So, we know the acceleration is 30 miles per hour per second squared. We know that the final speed is 120. I was starting at rest, so I do some algebra here. 120 minus 0 equals 30. 120 minus 0 divided by t equals 30, so just do the algebra. If you want, you could set this up as a proportion and cross multiply and divide, so you have 30t equals 120 minus 0, 30t equals 120, t is 4 seconds. All right, now, some people, you could also use this formula here, final velocity with average acceleration, and basically just solve for a, given everything else. All right, there's more than one way to get to the solution. All I ask is that you show the work on the test and, obviously report the answer as well. All right, 12 and 13 are just questions about graphs and so forth. So I'm going to just skip over those in the interest of saving time here. Number 14A. We're talking about golf balls initially at rest and is thrown from a cliff, initially makes contact with the ground 2.5 seconds later. The downward direction is positive. We have positive 9.8. So we want to first figure out what's the speed of the golf ball just before impact. Here it is, 24.5 meters per second. And then for part B, the question is asking you, based on question 14A, how far did the golf ball fall? A lot of people were missing parts B on this one and on number 16. So here's everything set up correctly. Again, position with average acceleration formula. Since we're talking free fall, A and B, it's a free fall problem here for number 14. Whenever you're talking free fall, the acceleration due to gravity is 9.8. All right, this is something you need to keep in mind. So, plugging everything in here, you have 0 times 2.5 over here. Again, think order of operations, PEMDAS. This is just 0 over here. So all we really need to focus on is everything to the right of the plus sign. 1/2 times 9.8 times 2.5 squared. When you solve all that, multiply these three numbers together, you get 30.63 meters. So the question is, how far did the golf ball fall when it was traveling this fast? Just for impact, it fell 30.63 meters. Okay. Now, what we're going to do here is I'm going to stop the video for a second because I need to